Hi, my name is Patty Davis, and I've been doing some research on algae biofuel. One of the most pressing problems that our society faces today is that our fossil fuels are running out and a new energy source is needed to take its place. One possible solution that is in the process of being developed is algae biofuel. Algae biofuel could provide sustainable energy that can be used as a direct replacement for the fuel we currently use, and from it we can extract diesel fuel, jet fuel, and gasoline. While there are some other biofuel solutions out there, such as grease car conversion systems that run on oil from fryers, ethanol from corn, and palm oil, they each have their own drawbacks that cause them not to be the best solution. Grease car conversion kits use vegetable oil from fryers for fuel. While this is a great idea to dispose of an otherwise useless waste product, the main problem is that the engine and the vegetable oil both need to be warmed up before they can be used, and diesel fuel is still needed to start the engine. Once the engine is warmed, then the grease can be used. The availability of grease is also another problem that would prevent it from being an ideal replacement for fossil fuels. The amount of grease is limited to the amount that is left over after frying foods. Ethanol from corn is also not the best solution for a sole replacement for fossil fuels for a few reasons. We can't use over 5% of ethanol in a fuel mixture because at higher levels it brings too much water into the system, which can damage the engine. It also has a lower energy density. It takes just as much energy to process ethanol for fuel as it provides for fuel, which isn't very efficient. Another problem with ethanol is that valuable farmland needs to be used to produce corn for the ethanol that could otherwise be used for food production. Then there is palm oil. Although many people thought palm plantations might be a good solution, it has turned out to be an ecological nightmare. Palm plants need to be grown in the tropics, and to create the farmlands to grow it, large stretches of tropical forests need to be cleared. Creating farmland for palm plants destroys natural ecosystems. As if that weren't enough, the land is cleared by burning vegetation that currently grows there, putting more pollution into the atmosphere. Algae biofuel does not possess any of these limitations or environmental consequences and can be made into fuel that could be used in engines that are currently in vehicles today. Algae grows much faster than other corn or palm crops. It is the fastest growing plant on Earth, able to duplicate its biomass 2 to 6 times in 24 hours. You can see from this graph that over a 1-year time period on 1 acre of land, if corn is grown, you can expect to harvest 25 to 28 gallons of oil per acre. If palm plants are grown, you can expect to harvest 6,700 gallons of oil, while algae has the ability to produce 20,000 to 100,000 gallons of oil per acre per year. Much better production value. Another benefit that algae possesses is that it can be grown in areas that are unsuitable for food crops, such as deserts, salty areas, and wastelands. To grow algae, it takes sunlight, water, and nutrients. The nutrients consist of nitrogen and phosphates. These nutrients happen to be what is left over from our waste processing plants. These byproducts are currently an environmental hazard that can contaminate rivers and lakes when not disposed of properly. Algae biofuel processing plants could use these nutrients to grow the algae, removing them from the wastewater. This would in turn clean the water and allow it to be safely disposed of in the waterways without contaminating the environment. There are many different types of algae. Researchers are currently examining the many different strains to determine which ones are most suitable to be used in processing biofuel. The reason algae is so promising is because it naturally contains large amounts of fats that are produced at a large volume. These fats consist of hydrocarbons and lipids that can be easily processed into fuel. Many of the oil deposits that we use today were created in part by algae that lived many millions of years ago and died off and sank to the bottom of lakes. Some algae can be grown in fresh water, while other algae thrives in salt water. Temperature also can affect the growth of certain strains, and research is being done to find out which strains grow well under what circumstances. This would allow for certain strains to be grown in different areas of the world according to a region's abiotic conditions. There will likely be crop rotation in algae growing facilities in the future, with some strains being grown at different times of the year due to temperature or sunlight differences. Many different growing methods are also being tested to see which is best suited for algae production. While large ponds would be the most cost-effective way to grow algae, they would be left open to contaminants from the environment. Testing is being done to grow algae in large research facility ponds to see what factors could influence algae growth, such as insects and bacteria. Other methods that have been developed for growing algae look like something you would see in a Star Wars movie. Vertigrow biofuel algae reactors use large bags that allow algae to circulate through the system. A benefit of this closed system is that water doesn't evaporate and it prevents contaminants from entering the system, and it also allows for more algae to be processed in a smaller area of land. Other testing is being done to see which strains have symbiotic relationships. For instance, a blue-green algae can be grown with a green algae and the two species can support each other. The blue-green algae will take atmospheric nitrogen and fix it into nitrates, which can be used as a fuel source for the green algae, which would eliminate the need to add nutrients. Atmospheric air is pumped through the algae ponds, which removes carbon dioxide from the air. This also has the added benefit of being the fastest way to remove carbon dioxide from our atmosphere. It is estimated that it would take about 30 to 40 million acres of algae farms to replace the quantity of fossil fuels that we currently use in the United States each year. As promising as algae biofuel is, some limitations still need to be addressed in order to make algae biofuel a competitive product. Bringing the cost down is one of the major hurdles that researchers are trying to overcome. With current production techniques, algae biofuel would cost about $10 to $60 per gallon to produce. Much research is currently being done to scale up production and begin producing a continuous product. The big challenge is that this has never been done before on such a large scale with any microorganism. We do have experience with producing other microorganisms to aid in the production of cheese, beer, and medicines, but not at nearly the quantity that would be needed for algae biofuel. The first step in producing algae biofuel is to grow the algae. This will take a few hours to a couple of days depending on the strain. Once the algae is grown, it is starved of nutrients. When the nutrients become unavailable, algae will take all of its energy and store it as fat. At this point, it is ready to be harvested and broken open. Solvents are used to separate the fats from the sugars. The solvents are then evaporated from the sugars, and the remaining meal can be used to make food for livestock, while oil can be turned into fuel. While most companies are trying to create algae farms that make use of sunlight and photosynthesis to grow algae, a company called Solarzyme in San Francisco is trying a completely different approach. The algae are put into tanks, fed sugar, and grown in the dark inside of huge stainless steel containers. By skipping the use of photosynthesis and allowing the algae to feed on sugars, they claim they have increased the oil production while reducing production costs. The sugars consist of a brown paste called bagasse. Bagasse is a waste product that is left over from sugarcane production. The algae that is being grown with this solution can double in size every 6 hours. The diesel fuel that is extracted from this process is chemically indistinguishable from diesel fuel made from fossil fuels. In 2 years, they hope to bring the cost down to $60 to $80 per barrel, which would make it competitive with $80 per barrel oil. Big oil companies have also taken notice, and many are investing in the production of algae biofuel. In 2010, Exxon alone invested $600 million. Other funding has been contributed by the Department of Energy, who provided more than $185 million in grants for algae biofuels. Bill Gates from Microsoft has contributed $100 million to a company called Sapphire Energy Incorporated, who is also involved in creating algae biofuel. The UK government has also contributed £11.7 million to 9 universities for algae research. Also in Japan, the Toyota Corporation is also involved in creating these new biofuels. Some sources state that we can expect this biofuel to enter the market in the next 3 to 10 years. The possibility of growing algae for biofuel is a really exciting opportunity that has the ability to completely reshape our future. It could eliminate our dependence on foreign oil, and it could change the world for the better by removing excess carbon dioxide from the air. Thank you.